All right, welcome back. So today we'll focus on the power station. You have recap on what is energy and how energy is converted. So today we'll focus on the power station itself. We have a number of power stations all over Singapore, and these power stations are very important in converting energy itself. Okay, so most of the electricity is produced in power stations. The power stations in Singapore use fossil fuels, and in specific, the fossil fuel that we use is natural gas. Okay, why natural gas? Because it's one of the most efficient, as we have studied the last time, and it is easy to be transported over to Singapore. We get it from a lot of countries. Okay, this is one example, the Senoko power station at Sembawang. So it looks like this, where we can remove waste gas or any other materials through these long chimney pipes. Okay. All right, so a power station has four parts. Let's go through these four parts together. So how does the power station actually produce electricity? We have done this before, so this is also a recap. Number one, let's focus on this part. At the furnace, so this is what we call as a furnace, Furnace, furnace. The fossil fuels are burned. So you put in the fossil fuels here and you let them burn, okay? Put the fossil fuel in, let them burn. What will happen? It produces heat. So now heat is produced. When heat is produced, what will happen? You see here there is water here. This is water. So inside this thing called a boiler, this whole thing is called a boiler. The heat is produced from the burning of the fossil fuels, and it used to boil the water here. This water will boil and it will change into water boils and change into steam. Okay, so the steam will rise up. Very good. Let's look at the next part. So steam is produced. Remember, steam is here. Steam rises up. What happens? Does it go? Next, it goes on to turn the steam turbine. So in this case, we go on to the next part, which is the steam turbine. So we went from the furnace, from the boiler, into the steam turbine. So in this steam turbine itself, it turns the steam turbine. All these things will turn. And the steam turbine then turns the generator. So this is the generator here that produces the electricity. Remember in the previous chapter, we talked about in this generator, there is a magnet. This magnet will spin and it will produce electricity using our hand crane that we used the last time, where we use our hand to turn and then it produces electricity. Remember, this is the same function. So the steam goes in, turns the steam turbine. When it turns, it has kinetic energy. This steam turbine will then turn the generator. The generator will then produce electricity. Okay, so this generator, when it turns, it also has kinetic energy, and then it produces to give electrical energy. All right, good. So this is an example of a generator. As you can see, it's very, very large. What is a good example to show this into? Remember the time in the science lab, we use this windmill here. All right, it's the same thing. You give a bit of push on this side, cause it to turn. The turning of the generator inside here, it will turn clockwise, and then it will produce electricity such that it will be channeled to different places. So the next question, not next question. Let us run through again, how does this steam actually move? Okay, so energy produced from the furnace here heats up the water, steam is produced. So let's draw the arrow. Steam goes up here from the boiler and be channeled into the steam turbine. The steam turbine will spin this turbine, goes through, this turbine will spin, and then once it reaches here, it will condense, move through here, condense even more, and then goes back into the collection point. Okay, so this is how the steam is used. Once it's used again, the water can channel back in, and then it recycle in a closed loop. Okay, so what is the energy conversion? At the furnace, where is the furnace? Let's recap again. Where's the furnace? The furnace is here. Okay. So at the furnace, your fossil fuels has chemical, remember, potential energy. This chemical potential energy is then converted into heat energy because the fossil fuel produces heat. Then it goes into the boiler. In the boiler itself, then is heat from this fossil fuel, so then be used to boil the water and change it into steam. So that's why when this steam is there, it has kinetic energy. Then this kinetic energy of the steam will use to turn the turbine. So where are we now? We are now in the turbine. The turbine will spin, that's why it has kinetic energy, followed by going into the kinetic energy of to produce electrical energy, and this is in the generator. So in the generator, the kinetic energy of the turbine will be changed into electrical energy. Okay. So what happens after that? That is in your power station. Electricity have to go to your house. So what will happen is electricity will be distributed to our homes. Draw the path of how electricity will be transferred to our homes from the power station. So power station produce electricity, goes here, goes through here, goes here, goes here, into your substation, into your home, then into your mains. So this is how electricity moves from the power station to your home. Besides the power station, what other things can produce electricity? One, we have batteries, or what we call as dry cells. Second, we have also your phone battery. It is rechargeable. Not all batteries are rechargeable. Why is this good? Because we can use it on the move, which means that this is portable for use. Okay, so what is the energy conversion that takes place when you use a battery? Good. In your battery, you have chemicals inside. So it stores all energy as chemical potential energy. When you put into your toys, you put into your laptop, so what will happen? Electrical energy will come out. So it changed from chemical potential into electrical. Good. Now what happens if you are now charging it? What if I'm charging? You connect your charger to the mains, right? So what comes out from your main switch? Electricity. So electrical energy will then be moved into your battery, and then it will store as chemical potential energy. So this chemical potential energy itself will be stored in your batteries, and it can be recharged. Okay. What other sources are there? Remember, we can have solar energy. So solar panels can convert light energy from the sun to electrical energy. At the same time, this is a renewable source of energy. Recap, renewable source of energy. So what energy conversion takes place in the solar panel? Light energy will be converted straight into electrical energy. This is for your solar panel. So with here, we will end off for this chapter, and let's do some practice, right?